All right, guys, we are moving on to Module 2, Lesson 1. This is Mrs. Mills, and I am going to be doing our videos for Module 2, which focuses on metric measurements. All right, we're going to start off with distance, and today we're going to be talking about centimeters, meters, and kilometers. So the first thing we're going to do is talk about some conversions that you're going to need to know, and these are going to be things that you'll have to memorize over time. So when you think of a centimeter, it's important to know how long a centimeter is. And I want you to think of a staple. Okay, so that's obviously very small. The length of a staple. A centimeter is quite small. Then you talk about meters, okay? Think of a meter stick. We have meter sticks in our classroom. A meter is typically about how tall a countertop is, so I want you to think about the height of a countertop. Typically that's how tall countertops are, plus or minus a little bit. And then you have a kilometer. Notice how we're going from centimeter to meter and then kilometer. Kilometer is going to be even larger. And I want you to think, let's see, probably about the distance. So we're talking about distances, lengths, height. Distance from, let's say, school to about the gas station or the post office. Distance from school to, I'm going to say the post office, if you guys know where that is. Okay, so we start with centimeters, which is small, meters, which is a little bit bigger, and then you have your kilometers, which is pretty far distance. Okay, now it's also important, we're going to work on those conversions underneath the table, to know that there are 100 centimeters in 1 meter. And you are welcome to pause this video and find a meter stick if I don't already have them out, and go pull out a meter stick and notice that there are 100 centimeters in a meter. Now, if we're talking 1 kilometer from here, from the school to the post office, there are 1,000 meters. So if I were to lay 1,000 of those meter sticks down right in a row next to each other and make a path right to the post office, I'm estimating that there would be 1,000 of them. Plus or minus a few, because I've never done it before, I don't really know. 100 centimeters in a meter and 1,000 meters in 1 kilometer. So then let's practice that in our distance chart. We already said that there is 1 kilometer for every 1,000 meters. So that's going to mean that if there's 2 kilometers, there would be 2,000 meters. Now, we don't need to write the M after this because we're putting in a chart that's already labeled at the top. So if there's 3 kilometers, 3 times 1,000 would get us to 3,000. 7 kilometers would be 7,000 meters. Okay, notice I'm multiplying by 1,000, so I'm tagging along 3 zeros each time. 9 kilometers, there would be 9,000 meters. And then, I think you guys were supposed to have, let me fix that to 70. 70 kilometers. Now, if you remember, we were tagging along 3 zeros each time we were doing this. So we're going to need to put our 7 and then 3 zeros. There would be 70,000 meters in 70 kilometers. Now, we could do a lot more conversions with this, but for sake of time, we're just going to do that small table. This is the important part for you to remember right now. All right, so let's put this to work. We're going to do some addition and some subtraction today. So take a look. We have 5 kilometers plus 2,500 meters. Now, we have 2 different units. Okay, we cannot just stack these and add. There's actually going to be 2 different ways that we can solve this, and there are multiple more, but I'm going to show you the two that I think you'll prefer to work with. Okay, so the first thing that I would like to do is to go ahead and change these to be the same unit. Now, I just learned that there are 1,000 meters in 1 kilometer. So if there's 5 kilometers, that's going to be the same as 5,000 meters. So I just converted 5 kilometers to 5,000 meters. Now, because I have meters and meters, I can stack them and add. Meters plus meters. They have to be like units. Okay, you can't add apples plus oranges and get only oranges. Here we go. I'm going to bring the meter rate down. So 0 plus 0 equals 0, 0 plus 0 equals 0, 0 plus 5 equals 5, put my comma, 5 plus 2 equals 7. I get 7,500 meters. Now, if you look at this, I know that there's 1,000 meters in a kilometer, so I can convert that 7 right to 7 kilometers, and my 500 stays meters. You have to have 1,000 meters at least to make a kilometer. And I had 7,000, but 500 isn't enough to make another kilometer. So I know my answer is going to be 7 kilometers, 500 meters, or if I keep it in my smaller unit, if I keep it in meters, I get 7,500 meters. These are both the same. They're both accurate. This is called mixed units. Why mixed? Because I have a mixture of different units. I have kilometers and I have meters. Okay. Now, speaking of mixed units, what if I wanted to change my 2,500 into mixed units, then add it to my kilometers? I could do that as well. So what I could do is I could keep my 5 kilometers the same and add it to 2,500 meters, but I have to convert it. 2,500 is the same as 2 kilometers, 500 meters. Okay? Notice how I put a space between these. I kept them kind of separate. It is nice to keep that space to show your mixed units. If you'd like, you can say, well, 5 kilometers has 0 meters over here. So if it makes you feel better, you can put 0 meters over there. Now that I'm stacked, I can go ahead and add. So I have 0 plus 0 equals 0. Oh, I'm going to put my unit down there. 0 tens, 5 hundreds. Now I can go over and add my kilometers. 5 plus 2 equals 7 kilometers. So there's my answer. And if you'll notice, I got the same thing. 7 kilometers, 500 meters. And that's in mixed units, kilometers and meters. 2 different types of units. I could convert that if I wanted to my smaller units and keep it in meters, which would be 7,500 meters. All right, let's try another one. 1 kilometer, 734 meters, plus 4 kilometers, 396 meters. Now I have an A and a B side. The first side we're going to do similar to what we did over here and convert both to meters. So let's convert these both to meters and keep same units. So 1 kilometer is going to turn into 1,000 meters. Simple enough. Plus my 734 meters. Okay. And we will get 1,734 meters, which is the same as, I can convert it back to kilometers and meters into my mixed unit. 1,000 would turn into, oh my goodness, what am I doing? So I was just showing you how 1 kilometer, 734 meters, will turn into 1,734 meters. I'm going to back up so that I can actually leave some space to show my work now. So it's going to be 1,734 meters. Okay, I showed you the work, but eventually I expect that you guys do this step in your head. You'll know that however many kilometers you have will turn into your thousands. Okay, and your meters will stay the same. Now I can go ahead and add my 4 kilometers, 396 meters. 4 kilometers will turn into 4 thousands, and 396 will stay the same as meters. So I've now converted everything into meters. Over here, I'm going to kind of work parallel to this problem. I'm going to keep my units the same. 1 kilometer, 734 meters, plus 4 kilometers. Notice how I'm lining up my kilometers, lining up my meters. Okay, notice how over here we just have meters. Over here we have mixed units. We kept our kilometers, we kept our meters. All right, let's go ahead and add 6 and 4 equals 10, regroup the 1. 13, regroup the 1. 11, regroup the 1. 6,130 meters. Okay. Now, over here, we have mixed units. So we're going to start with our meters. We have 10, 13, 1,130 meters. We're going to come back to that. And over here we have 5 kilometers. Right away, you guys should notice something about my meters. My meters went above 1,000. Once we switch into thousands, we can take one of those thousands out and turn it into a kilometer. That 1,000 right here gets to turn into a kilometer, and the rest stays meters. We're going to go ahead and add that kilometer to 5 kilometers. 5 plus 1 equals 6 kilometers, 130 meters. So if you end up having something in the thousands place in your meters, you know that you can take those thousands and convert them to kilometers. So we got 6 kilometers, 130 meters, and that is the same as the answer we got over here. What we could do is convert this back to mixed units. 6 kilometers, 130 meters. Bingo. All right, moving on. Now we're going to do a subtraction problem, actually 2 subtraction problems. We have 10 kilometers minus 3 kilometers, 140 meters. So the first thing we're going to do is convert to meters. 10 kilometers would be 10,000 meters. Tag on 3 zeros, multiplying by 1,000. Minus, we would have 3,000 meters plus 140 meters is 3,140. And then we can do our subtraction. This would become a 0. This would become I'm going to skip a step there, 9, 9, 9. Oops. 10. So we can do 0. 10 take away 4 is 6. 9 take away 1 is 8. and 6. And bring our unit down. 6,860 meters. Not too bad. Now the other way would be to keep them the same. But I want you to think about something. If I were to say, okay, I'm going to keep this 10 kilometers, and I'm going to keep my 3 kilometers, 140 meters. If I have 0 meters over here, how am I going to take away meters? I have nothing to take away. I have 140, but I have 0 at the top. So what we're going to do is we're going to simply rename. This becomes 9, and we're going to give that kilometer that we took away over to this side. We took away 1 whole kilometer, which is the same as 1,000 meters. Okay, this becomes a 0, this becomes a 9, this becomes a 10. 0 take away 0 is 0. 6, 8 meters. 9 take away 3 kilometers is 6 kilometers. Same answer. This one's in mixed units. This one is in the smaller unit because we kept it in meters. Okay, same answer, but you'll just have to pay attention to what the directions ask. If they ask you to keep it in the smaller meter, you keep it in smaller units, you keep it in the meters. If they say we would like your answer expressed in mixed units, you need to keep your, I missed a K there, kilometers and meters. All right, last one. Solving a word problem. Sam practiced his long jump in PE. On his first attempt, he jumped 1 meter 47 centimeters. On his second attempt, he jumped 98 centimeters. How much farther did he jump on his first attempt than his second? So I can tell that I'm going to have to do some subtraction here because they want to know the difference between his first jump and his second jump. So let's go ahead and draw our tape diagrams, which I know I already got you started, but I still have to draw mine. So I have here's his first attempt, and that was 1 meter 47 centimeters. And then we have a second attempt, which was not as far. It was only 98 centimeters. Not even a full meter. And they want to know how much farther did he jump on his first attempt. So I'm going to be looking for this right here. Okay. So I'm going to have to do some subtraction. I'm going to have to take away his second attempt from his first attempt. Now, like I said, there's multiple ways that we can do this. I'm going to go ahead and do the way where 1 meter 47 centimeters minus 98 centimeters. Okay, now you'll notice right away I can't do this. I can't subtract 98 from 47. So what I'm going to do is I'm going to cross that meter off. And if you remember back to the beginning, that 1 meter equals 100 centimeters. I'm going to have to add that 100 centimeters that I'm exchanging it for to 47. So it will turn into 147 centimeters. Now I can go ahead and do my subtraction. So I'm going to cross off my 4, make it a 3, make this a 17. 17 take away 8 equals 9. Get my centimeters there. Cross this off, make it a 0. This a 3. 13 take away 9 is 4. 49 centimeters. So how much farther did Sam jump on his first attempt than his second? Sam jumped 49 centimeters farther on his first attempt. I apologize. You can hear Gianna crying downstairs. All right, guys, I know this is a long video, 20 minutes worth, but hopefully you guys are getting the hang of this. Go ahead and start your problem set.